Hello reviewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SpaceX August update, specifically focusing on Starship. So let's dive deep into it. Now, when we last saw this puppy, it got blown to smithereens. So they really had to fix these things after 20 April 2023. So this was the remainder. So they had to fix it. So they rebuilt it from scratch, meaning these things were remained, but everything below this was redone. Basically, pylons were grafted into the soil, deep, strong, thick pylons with boatload of concrete. And I mean serious amount of concrete. And this time all layers are being interconnected. For example, if you look at the scene, what do you see? You see some pylons and then you see some rebars here. What are these rebars? These rebars are the connecting loop, so to say. Now here's the mean, that's rocket, when they fired it, it was not the biggest and most oomfish power that they had. They could go even more. That means this will become basically what we call one use, one throw. Basically uses it one and it's gone poof. So they needed to reinforce it. Now they could have done the dumb system, which they would have like just concrete base and they pour concrete more on top of it, but that's it dumb. So they did something better. So what they have is what we classify as interconnect block, meaning they put pylons, as much pylon as they could physically. I mean, like, you should watch the live stream. Like, the pylons they put is like, damn, big, thick, long pylons. So they jammed that puppy in there, and after that all those pylons had exposed rebar. Now this is a common tactic if you needed one to build something robust. So exposed rebar was literally a new formwork of rebars were created and tied together. So now it's structurally tied together, new layer of concrete poured on top. Then they repeated this concept. Now everything, this whole block, this whole section is literally tied together using rebars and using concrete. So fundamentally it's one mono block now. Like, it is strong, absolutely. What does that mean? That simply means even if the basically whole rocket goes kaboom, this top part may be destroyed, but this bottom part will be like, bro, I got this. Did something happen? Like, this is the only thing this could damage it by now is like a nuke. And I'm not joking. That's how much concrete they poured into it. This is a bunker grade rebuild structure. So what does this mean? What does this afford? Like, they did pour money into it. So what was the benefit? Benefit is now all they have to do is refurbish this, meaning no matter how many launches they are doing, even if water deluge system fails, they will not have this gases creating a crack and then going inside the crack and then spreading apart the layer. That's why I said the last time it was layers were not interconnected. This time they made sure all layers are interconnected in all three dimensions, X, Y, and Z. They are interconnected with rebars. So it will not, even if let's say there is worst case scenario, water deluge system fails, hot exhaust just punches through it and then it goes on the bottom, it will literally see concrete. It will not be able to create a cavity and cause boom boom. So fundamentally this is absolute, and all they have to do is put fondue layer on top of it, which they have done. Now you're like, wait a minute, wouldn't that layer fail last time? Yes, it failed because it was not designed to it. They exceeded the design rating. Water deluge system supposed to tame it down, then anything else, any stray jets of hot gases supposed to be handled by fondue layer. That's what its intended purpose is. It should be able to handle it. But worst case scenario, let's say they failed, that water deluge system fails and hot exhaust just starts to blow torture. This is so big, so thick, so robust. It's like, bro, I got this. I got this. And all they have to do after that bad incident, regrout it again. So this is their like long-term investment. Like, they built it, they have to forget about it at least for the next 50 years. So they really went all in into that. Like, pylons on top of pylons with some extra pylons. And then they were like, hey, what if we put extra pylons? Yeah, and yes, pylons are till that far out, not only in the center, or till that far out pylons are there. So it's like, bro, it's not going anywhere. No earthquake, no tsunami, nothing. Anything on top of that, that may disappear. Anything below that, it's like, bro, I'm here. We good. So launch pad, we good. Then we come to the water deluge, this puppy. So they need a lot of portable water. Now you cannot use seawater for this sort of system. Why? Seawater has this tiny thing known as salt, and if you evaporate salt, how should I put this? It corrodes everything. It's brutal, cruel, and metal do not like it. Flat out, it annihilates metal. So you cannot use seawater. I mean, like, you can use it, but for once. So for that reason, they have to use portable water. If you are not familiar with that logic, portable water simply means drinkable water. I have no idea why it's called portable. Do not ask me. So the idea is it's portable water. The best would be distilled water, but that would be too expensive. Portable water is the next best solution. So portable waters are coming using trucks into these puppies. Now these puppies are huge. Like, they do not look huge, but because they're not surrounded by normal things like normal cars and all that, but they're huge. They are like freaking huge. So what is the capacity of these puppies? Well, you are looking at around 1,400 kiloliters of water. Now be mindful, that's an estimate. It could be off, but reasonably more or less it would be in that ballpark, so to say. And be mindful, these tanks are pressurized puppies, meaning they are not just like tanks, they are solid tanks with thick walls, so it can handle very high pressure. So this is pressure fed system. Now this is completely different from what everybody else does, and heck, what even Falcon 9 does. If you look into SpaceX launch site, especially with Falcon 9, you will see there is a giant water tank which looks very tiny. Why it looks tiny? Simply because it has a ludicrously thick pipe. The tank is huge. It looks tiny because of the pipe, and we are supposed to see a tank to pipe ratio that is like almost invisible. Pipe supposed to be almost invisible, so you're like, oh, water tank. That's why whenever you look at that NASA picture, the tank looks small. Tank is not small. Is that pipe proportion is huge. It's almost like a bottom fell off. It's huge, and they are using gravity to take care of the situation. So that's awesome. That's dumb, simple, absolute. It works. Here they are using pressure, so it's far more complicated. They do not have the love of gravity, they have to put the love of pressure. So it's a pressure feed system. Now how they are pressurizing it? They are utilizing nitrogen. So these tank canisters that you are seeing is nitrogen. Now why they are using nitrogen rather than compressed air? Because again, they will be using this regularly. Why pay for nitrogen? Well, it will cost more or less the same, but this will be simpler for them. How? Well, simply because when you are buying liquid nitrogen, you're buying pure gas. If you expand liquid nitrogen into nitrogen gas at high pressure, you get nitrogen gas. You do not get dirt, grime, nothing. If they wanted to do this with compressed air system in that area, they would need filters on top of filters with some extra filters to make sure that they can actually run a compressor and have clean air. That's just the clean part. On top of that, because air has what we call humidity, humidity also condenses into these tanks. And believe it or not, there are life, things that can grow in that condition. Like there have been life form that have been found inside basically air storage tank. What does that mean? That simply means it has biofouling, meaning it's not only just things, you also have to handle how those biological things will work. So that creates a very serious issue. You do not want this potable water to be contaminated. You do not want your tank to be corroded from the inside because of the water. So the only way you can have that, nitrogen. Now, why did they choose nitrogen? Simply because they are using it nitrogen anyway. And there is a probability, rumor, I cannot substantiate it, but it makes sense that SpaceX is gonna put an air distillation plant next to them. Why? Well, air distillation plant solves a lot of issues for them. They consume nitrogen like there is no tomorrow. They consume oxygen like there is no tomorrow. Those things can be directly extracted from air. Right now, they are buying it. So where they are buying it from? An air distillation unit. So not only they are paying for the electricity of that air distillation unit, they are paying for the profit, and then they are paying for the transportation. That means fundamentally, if they can get the electricity, which mind you, this time they have high voltage line coming to them, if they can get the electricity, it would be economical to have that plant right there. It will also increase their cadence because they will have lot of nitrogen supply and lot of liquid oxygen supply. Again, this makes sense, and they have talked about it, but it's not absolute. I cannot give you like, this is the air distillation unit, this is where it is. It's not sorted yet, but it makes logical sense to do. It will literally save them money. It's like, instead of, and also cadence will also improve. So fundamentally they're going to do that. And these thick pipes, manifold, you can see these pipes are huge puppies. So they're going to dump the water, 140 kiloliters of water, and this puppy should work for few seconds, meaning startup, little bit of hassle, and then it should be able to launch. Now they cannot just refill it again, so that's another issue. So if they had to scrub it, they have to detank it. That's another reason why they are really focused on how to detank the rocket, because if this puppy runs out and they are like, hey, a rocket is green, good to go, they have to like scrub the launch, because this will be like, bro, I'm out. So water deluge is the system. This is the water part of it. Be mindful, the third tank has been added when I'm making this video. I could not find a good image of it. Now let's talk about the shower head. I have linked a very detailed deep dive video of it down below, but that's 50 minutes long if you want to go deep into it. But here's the essence of it. So essence is, we have thick steel plate. Like this puppy is thick, like idiotically thick, like so thick, plasma cutter is not a good idea to run on this. The only thing that can cut this with any sort of finesse is a water jet. So it has angled holes. All the holes are not just directly straight up, because you have to understand there is no point fighting with rocket engine. You do not want to fight with rocket engine. Rocket engine is doing what you made it to do. So why the heck you want to fight it? All they are doing is creating what we classify as a virtual trench. They are creating a water. This is what you see. This cone. The idea with this cone is that it's gonna push the gas. It's gonna basically stimulate the gases. It's like, hey, instead of directly going down, how about you go there? How about like just all it has to do is change that degree by 90 degree. They're not supposed to like, okay, I'm gonna stop you. It's not like, water shield and all that jazz. No. It's just like, hey. It's like how tanks have sloped armor. Instead of physically sloping like what we have in normal French trenches, they are using water pressure and a lot of water to do that. And it also helps them with thermal, simply because water has this benefit of like actually absorbing a lot of it when it does phase change, meaning if it's liquid, if it goes to steam, it consumes a lot of energy. So this keeps the whole area cool. Even though there is a giant blowtorch on top of it, it will be like, surprisingly cool. Everything around it will be surprisingly cool. Now be mindful, I'm talking in rocket launch terms, not cool as in like, I can be there, I can do sunbathing. No. Not that cool. Cool as in like, metals would be like, less stressful. So they are doing that. And that's why center has the most pressure, because center has to suffer what we classify as curtain effect, meaning when you look at this panel, the center place is the most important part. That's the part that is getting GG amounts of pressure. Why? Look at from its point of view, like plate looking up at the rocket engine, what they're saying, there is a ring of engine at the outside. That's awesome, because 50% of those engines exhaust will go outside if you do nothing. So okay, only 50% remain inside. Here's the problem. Falcon, basically this Starship is huge, meaning it has multiple rings of engines. So outer engines, 50% of energy goes outside. Awesome. But 50% gets trapped inside. Then another cycle, again the same issue happens. Now this time 75% is trapped, because again 50% was being pushed. So 75% is trapped. Now look at the 3 core engine. Yeah, those engines are only going down. So that's why the center has so much pressure. Thus, to make sure that 3 engine that is in the center is like, bro, no. You do not want trapping there. You do not want air to get locked there and create a channel, and then that channel will be like a blowtorch, and that puppy will damage the plate. I do not think it could cause too much damage now to the concrete, but it will annihilate this plane. So center has the most amount of attention put into it, because outside it's already going away anyway. So you have to make sure the center part is taken care of. Static fire, when they did this puppy with static fire, it gave optimistic result. Now be mindful, static fire was not all like full force, or it was not even full duration. They're supposed to be for 5 seconds. It was not that. So however, that being said, from an engineering point of view, the results were optimistic. Like the likelihood of this failing now, unless they have a water failure, like again things could happen, let's say a valve could jam, nitrogen supply could fail, or something else, barring those things, this puppy should work. So optimistic result. Now be mindful, there are giant holes, like holes that are this size on the bottoms. You can see, even maybe able to see in the videos, it's huge holes. Now why are those holes there? Those holes are caps. You're supposed to open those caps and flush the system periodically to make sure dirt, grime, stuff do not go on top of them. Now there is another issue. This is a water hole. You have people around, these holes will gum up very quickly. So they have a steel plate that you can see, a smaller version of that. There will be steel covering on top of that. They will, when they launch the rocket, after that people will come there, they will put those steel cap. Then you can walk around on it. That steel will take care of it. This place can handle the physical pressure without any issue. It can even handle the temperature without any issue. Thermal expansion, was like, bro, I got this. What it cannot handle is dirt, grime, grease. So anytime engines are like being tampered with, welding, anything, stuff that is happening, that dirt and grime will jam up the thing. And worst case scenario, you jam up the center part, and yeah, that will be like, no. So for that reason, they have to create a thin sheet covering, metal sheet covering. So they cannot be like, oh, plastic and it like ruptured. No. Metal. Absolute cover has to be put on top of them. So it will be interesting to see how somebody will capture that. Whereas like they just launched it and then some people are running with giant steel plank, cover it. So this is the shower head part of things. And it would be interesting to see how they open it and flush it. Then we come to hot staging ring. Now this was announced last time in my last update video. Be mindful that time if you watch videos and watch artist rendition, they were giving curve here. Now the reason for that is SpaceX themselves were thinking that they literally had a mock-up where they actually tried to cut that, and that structure, the physical steel structure, was like carried around. So people actually thought, oh, this is what they're gonna do, and then changed it. Now be mindful, in that one also said I do not think that was the final design. This design is much further ahead, but I'm pretty sure this will also change. Now be mindful, SpaceX does have a habit of changing too much, and this is not tested. Now this is a can crusher tester where these things, the cables will be tied down and they will crush it. This testing has been done. I could not find the footage, but it has been done. How do I know that? Because this is the uncooked stage, this is the cooked stage. You can see like other things are being welded, and this cap is now welded into a booster stage. So this has gone through the testing, but they did not do what we classify as destructive testing. You're supposed to do destructive testing on Mark 1. What does destructive testing mean? Meaning break it, flat out, as simple as that. Like if you know what you have built and you have data from destructive testing, then you will only test to a known factor. Meaning if that's supposed to take care of X, you will be like, hey, let's put 3X load. If that's your security margin, you're like, okay, let's push it 3X. Everything fine, everything working as it's supposed to. Nice, awesome. Disable the test and go ahead. But you do not know that. You are just calculating that. Even if it can handle security overload, you do not know by how much. That is why we have to do what we call destructive testing. Cars generally go through lot of destructive testing, as in like take the car, yeet it into a physical concrete block which is unmovable from its point of view, and just watch it burn. And yes, it has to be done, especially if you are designing something that has to be manufactured multiple times. So I'm reasonably sure this design will change also. And be mindful, is SpaceX, so it's like, yeah, of course it's gonna change. That's the one thing that is guaranteed. But because of non-destructive testing, I'm absolutely sure. Would it look any different? Maybe, maybe not. But this seems too many weldings are there. I do expect in the future variant they may make it a bit more easy to manufacture. So let's see. This is the hot staging part. This is in the system. We should see this launch in the next flight test. Then we come to the static fire. Now, static fire, a booster mine, happened on basically 6 August 2023. A few days ago. Basically 33 engines went all out, and this is what I was talking about, the curtain effect. Meaning the outer engines, they're like, bro, I'm good, like exhaust wants to go out, no problem. This center engine is like, I have a lot of air pressure around me, gas pressure around me that is trying to box me in. That itself is bad. Then the center engine is like, bro, I'm surrounded by 2 stages of rocket exhaust. I am trapped. That is why the center part has to be taken like with extra precaution, with extra pressure. So they did that. Now they did launch it. Now be mindful, it was not full throttle. Now it cannot be full throttle unless they turbo built their clamping mechanism, because clamping mechanisms is designed with the rocket in mind, and it's designed in such a way that rocket has a X amount of weight putting down. Fully loaded, maximum capacity. That's how the clamps are designed. If this rocket is fully loaded from liquid methane, liquid oxygen, payload, stage 1, stage 2, all the things, all the gizmo, all the jazz, like how much is supposed to weight. Let's say that is the X. So the clamps has to be designed that it can handle X putting it down, and then engine supposed to create thrust that cancels that X to 0 and then creates a positive load. Okay, so you need that X, then you need minus X. Then the moment that 0 value starts to go in positive direction, you're like, okay, now engines are creating positive thrust. Then clamps will be like, I got this. You sure? You are absolutely sure that you're good, because gimbal will not work if thrust is not there. It needs positive thrust. So positive as in like in terms of control, like you can gimbal it, but it won't do anything if there is no positive thrust. So they're like, it needs to hold on for that few seconds, not even few, whole second. It could be like half a second. That clamp has to hold on for dear life in that time. But here's the deal. What if you change one variable? Let's say engines are there. Engine can go all out, bro. It's like, I'm good, bro. Engine does not care whether it's supposed to burn for like say, 10 seconds or 5 minutes. Engine is like, bro, my throttle value does not care about the time value. So what happens then? Well, the clamp will malfunction. Why? There is no X. The positive value will happen way too early. Because you can see that they did not load methane part. Methane is the topper tank, and you can see there was a only tiny layer of what we call condensation, icing over, so to say. Now, why is that? Well, it's what we call a boom protection. So in case of a boom, the boom remains a boom rather than kaboom. Because if you load up that much methane and something bad happens, yeah, the boom will become kaboom. You do not want kaboom. No, you don't want that. So that's why. But again, consequences, the clamps are like, bro, you have way too lightweight rocket and engines are creating way too much thrust. So I will go into positive even just as a spool up. So all the engines have to be like very chill state. They cannot be full out. This is a fundamental limit. Can they solve it? Yes, but they have to pay too much money and the clamps would be like overbuilt for no reason. And they did the testing. Target was 5 seconds. They only managed 2.74 seconds, which was odd. Now, why did that happen? Most likely, at this point in time, the outer engines had some issue with plumbing of gases and all that jazz. That created an issue where 4 engines just yeet out of there. Now, booster is designed in such a way that it can work sufficiently well enough where if you have 3 engines going yeet, other engines can like, I got this. But if 4th engine goes away, it's like, no, I do not got it. For that reason, the launch was basically static test was scrubbed. But overall, this was considered well enough. And be mindful, this many engines working and nothing going boom, that is like, bro, shut up, take money. That is that good. So I'm reasonably sure they should be able to fix the next launch that. Be mindful, this is Mark II engines. The Mark III engines that they are creating, those engines will be even more powerful. Those clamps will be like, bro, no, load up the goddamn rocket, full load, only then I can give you true positive lock. Otherwise, my lock will break before the engine even reaches full thrust. Now, again, it will work. It's just like you do not want that. You do not want your clamp to fail in static test. So this is some big problems that space has to deal with. So this is static fire part of it. I have linked the videos down below. So this was my presentation on basically SpaceX Starship August update. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.